Okay, good morning class. So today we're just marking exercise 4. And exercise 4 is on page 55. Alright, so here we go. So here we are told that draw the graphs of f of x and g of x on the same set of axes. Show clearly the intercepts with the axis and the coordinates of the 2 points on each curve. Write down the equation of the line above which f and g is symmetrical if there is one. Okay. We can see that this can be written as log x base 4 if there is a negative in front of it. So negative log x base 4. So this is actually reflected in the x-axis, y became negative. But okay, let's say we didn't know that. Okay. So we're going to draw the first graph. Log x base 4 graph. Okay. So just right here, the f of x, which is log x base 4. I'm going to use red for that. So this we said is going to go with x and y. Negative 0, 1 and 1. Negative 1, sorry, not negative 0. So negative 1 is equal to log x base 4. So you change that to exponential. So x is equal to 4 to negative 1, which is a quarter. That's a quarter there. Remember, we are drawing the graph x is equal to 4 to the 1. Okay. And then if I put 0 in here, I'm going to get 1. If I put 1 in here, I'm going to get 4. Now say you didn't know that. Okay? Then what I would have done, what I would have suggested is, you first work out the inverse function. Okay, so the inverse function gives you y is equal, x is equal to log y base 4. So y is equal to 4 to the x. I draw this table, x and y, minus 0, 1, 0, minus 1, 0, 1. So it will be a quarter, 1 and 4. And what do I do for its inverse? I swap it around. So I get that. Okay. So either way, you should get the right graph there. Okay. So if I draw that graph, so that is 1, 2, 3, 4, 3, 4, minus 1, minus 1, minus 1. Okay. So if x is a quarter, y is negative 1. If x is 1, y is 0. If x is 4, y is 1. So that's going to go through like that. Okay, and this is the f of x graph. Then the g of x graph, I do the same thing. G of x is equal to log x base a quarter. Again, I go with x and y. So minus 1, 0 and 1. Okay, so if I put minus 1 in here, it's going to give me 4, 1 and a quarter. So if x is 4, y is minus 1. If x is 1, y is 0. If x is a quarter, y is 1. Okay, I should have written the coordinate in there as well. It's a quarter and minus 1. So the graph comes close here. Doesn't touch it. This is the g of x graph. But what do we notice here? That is your line of symmetry there. Can you see that, people? So in other words, this is reflected in the x-axis. Okay? Very simple, no? Let's go with number 3. As we see, we're just doing the odd numbers. Alright, so let's go with f of x. People, what do you notice what's different here? There's a negative there, so it's reflected in the y-axis, x-axis. If it was reflected in the y-axis, x would have become negative. Okay? So as you can see here, earlier on I put a negative in front of you. So it was reflected in the, did I say earlier on x-axis? You guys don't remember. Okay. If the negative lies here, then the y became negative, which reflected in the x-axis. But anyway, let's go with f of x. That's your exponential curve. That's fairly simple. There's x and y. Minus 1, 0, 1. It's a third, 1 and 3. Let's draw. So 1, 2, 3. Minus 1, minus 2, minus 3. 2, 3. Minus 1, minus 2, minus 3. Okay. So a negative 1 gives you a third. You put negative 1 in a third. 0 and 1. 1 and 3. The graph comes close here but doesn't touch. That's your graph of. So the graph of g of x is negative 3 to the x. Again, same values on your x. So it's going to give you, if I put negative 1 is going to be negative a third, negative 1 and negative 3. So x is negative 1, y is negative a third. If it's 0, it's 1, minus 1. And if it's 1, it's minus 3. The graph comes again close, but does not. This is the graph of here. But what do you notice here, people? I can actually fold it close in the line. Y is equal to 0. Or you can say it's reflected in the x-axis. Okay. Easy, no? Too easy for your liking. Yeah, okay. Go with the last one, people, number 1.5. So the first graph, f of x. So where do I put minus 1, 0 and 1? In the x. Okay. The log, we put it in the y. Okay. So that's simply going to give us negative 1 is going to give us 1 over 5, 1 and 5. Lots of. There's 1, 2, 3, 4, 5. Minus 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, minus 5. We'll put it a bit lower. Minus 1, minus 2, minus 3, minus 4, minus 5. Okay. So negative 1 gave us a fifth. Negative 1 gave us a fifth, the value very close to your x-axis. 0 gave you an answer 1, 1 gave you an answer 5. So again, the graph comes close to the axis, does not touch, and this is the graph of f. You see that, people? And look at g. G of x graph. G of x is equal to log x base a fifth. So you put x in the denominator. And the values of negative 1, 0, and 1. Whenever it's log, you do that. Okay. People, we are also looking at, if you change this to exponential, is x is equal to 1 over 5 to the 1. If I change that to exponential form. So if I put negative 1 in the y, what do I get? 5. Put 0 in, I get 1. Put 1 in, I get a fifth. So, if x is 5, y is negative 1. Y is negative 1. You've x is 1, y is negative 1. Sorry, x is 1, y is 0. 1 and 0. Okay? And if x is 1, a fifth, y is 1. That looks very ugly. That is this point here. Again, the graph comes close but does not touch. Okay, and this is the graph of G, which is G. People, is this a straight reflection? Of course not. Okay? So, what you should note is that this is actually first reflected in this line here. Can you see that? And then it's reflected in the line y is equal to minus x. Not so. So if you look at this graph, the graph of f, if I reflect this down, let's take 1 point into account. This is now going to become 1 and minus 5, no? 1 and minus 5, which is here. This graph had to go through here, no? But what happens now? It becomes, that was swapped around, which is minus 5 and 1, and the negatives has changed around, which is this value here. Can you see that? So if something is reflected in the line, reflected in y is equal to minus x, the rule gets x and y becomes minus y minus x. That's the rule. Can you see that, people? So that is one way of looking at it. So firstly, the answer here would be reflected in the line, in the x-axis, and then reflected in the line y is equal to minus x. But I don't think the textbook has that answer. That is one way of doing it. Otherwise, we take note and say, okay, take all the green off. Otherwise, we could have said, okay, moving from exponential to log, it's reflected in the line, reflected in the line, y is equal to x. By doing that, by reflecting the line y is equal to x, the f of x graph, 1 and 5 becomes 5 and 1. And then 1 and 0 becomes 0 and 1. And the other point is now here. So that's that graph. Okay, reflected in the line y is equal to x. As you can see, from f to the inverse of f, which is reflected in the line y is equal to x. Then how do we get from the green to blue? Reflected in the x-axis. As you can see, by reflecting the x-axis, y becomes negative. So 5 and 1 becomes 5 and minus 1, and so on. So it's reflected in the x-axis, then reflected in the line y is equal to 0, or you can say reflected in the x-axis. Either one of the two will get you the mark. Okay, so I showed you two ways now in order to answer that question. Okay. And with that, it brings us to the end of exercise 4. Okay, exercise 5 will be a bit longer, should take us about 20 minutes. So I'll do that in tomorrow's lesson. 5 and 6. We'll conclude in the next lesson. The full lesson can be found in the description box below.